Hey, Econ folks, this is Ahmad. Let us talk about the derivative of function. In math, derivative of function is defined as the rate of change of a quantity y with respect to quantity x. And this sounds very similar to the definition of a slope. Derivatives are widely applied in economic modeling and theory because they are an invaluable tools used to measure the effects and the rates of change in economic variables and find the maximum and minimum value of the function. If we have a function of, let's say, y is equal to f of x is equal to x squared, then the derivative is commonly written like dy over dx, or f prime of x. I like this Leibniz notation because it's very suggestive of what is going on. But you have a freedom to use whatever makes you happy. So this is telling us that a small change in x, what will happen to your output? If you change x by a little bit, what happened to your output? So changes in x, a small changes in the direction of x, what will happen to your output? This is what it's telling you. So the derivative of x squared is equal to 2x, and you can write it in prime of x is equal to 2x is the same thing. So what is that telling us? It's telling us how fast the function is increasing. In other words, for the function of x squared, the rate of change at any point, the rate of change at any point is equal to 2x. And we can evaluate this at any particular point. For example, if x is equal to 2, then y is equal to 4. So that's what is telling us. Now, let us do another example because we probably do not have a simple example like x to the power of 2. We might have more complicated function. And therefore, we're going to have the two following examples. You can just write the question and then stop this video and then take the derivative of the function and come back and compare your answers, see if you have it right. Let's do this problem. Now, the first one is y is equal to 2x to the power of 4 plus 3x squared plus 2x plus 13. To take the derivative of this function, the first thing you have to notice is to see if the variable are the same or the variable is different. If the variables were different, there was more than one variable, then you cannot just simply take the derivative of this function with respect to one variable. So since we have one variable here, x everywhere, and there is nothing here, therefore it's one variable, therefore we can just take the derivative of this function, considering that this is a function of one variable. So to take the derivative of the first term with respect to x, then the 4 times 2 is 8x, 4 minus 1 is 3, it's 8x to the power of 3. Plus the derivative of second term with respect to x is 2 times 3 is 6, and then the derivative of the power is 2 minus 1 is 1, so 6x. Plus the derivative of third term with respect to x, we have 2 times x, the derivative of x, 2x with respect to x is 1 times 2 is 2, and the fourth term, we don't have any x here. Therefore, this is a constant term, and this constant term, we know that the derivative of any constant is equal to 0. Let's do the second example, and that example is a cost function. So cost function, we have x to the q to the power of 3 minus 4q to the power of 2 plus 10q plus 75. So we're going to apply the same rule here because we see q everywhere. So the first one is 3q squared because we bring 3 down and 3 minus 1 is 2. So 3q squared minus 2 times 4 is 8. 2 minus 1 is 1. So 8q plus the derivative of 10q with respect to q is 10. And the last term, we don't have any q. So we know that this is a constant, and also we know the derivative of constant is equal to 0. So that's two examples. But note that in order to take the derivative of any function, whether it being one variable or being a multiple variable in that function, you need the following rules that to take the derivative of this function. So the rules are as follows. The first one is a constant function. The constant function rule says that the derivative of any constant function is always 0. If we have f of x is equal to k, where k is constant, then the derivative of this function of f of x equals to k equal to 0, because k is constant and the derivative of this is 0. The second rule that you need to know is the power rule. If you have a function of f of x equal to x to the power of n, then basically you take the power, which is n, multiply it by the expression, which is x, and then reduce the power by 1. So you take the power and take the power, multiply it by the expression, and then you reduce the power by 1. So that is the power rule. The second rule is the sum difference rule. The derivative of sum difference, by sum difference, we means when you add two terms, that's you summing the two terms. But if you subtracting, it means you difference between the two. If you're taking the difference between the two, means you're subtracting one from another. But if you're taking the sum of the function of two functions, then means that you're adding the two functions. So the derivative of sum or difference of two functions, f of x and g of x, is equal to the sum difference of derivative of the two functions, sum difference of the two functions. And you can write it like this. Again, the derivative of sum difference of two functions is the sum difference of derivative of the two functions. You can write it like this, or you can write it for prime of x plus minus g prime of x. The next one is the product rule. So the product rule states that the derivative of a product of two differentiable function is equal to the first function times the derivative of the second function and plus second function times the derivative of the first one. So that's called a product rule. And also quotient rule. The quotient rule is, this is a method of finding the derivative of a function that is ratio of a two differentiable function. So if you have h of x is equal to f of x divided by g of x, then the way you take the derivative of this function is you take the derivative of what is in the numerator, f of prime of x, times what is in the denominator. You just write whatever is here, minus write what is in minus what is in the numerator, times the derivative of what is in the denominator, and then you square whatever is in the denominator. So that's the quotient rule, product rule, sum difference rule, power rule, and the constant rule is something that you need to know to take the derivative of any function being one variable or two variables. The only difference is that when you have more than one variable, then you can't apply these rules because it becomes a bit complicated, not scary. It's doable. It's just need a little bit of hard work, not very much. And that is we call a method of a partial derivatives. And partial derivatives means we have two arguments. We take partial derivative of that function with respect to the first variable, holding the second one constant. And then in the next step, we take the derivative of that function with respect to the second term, holding the first term constant. And this is called partial derivatives. And then in the following videos, you will see examples of those partial derivatives and also total derivatives. I hope you like these videos and it's useful to you. You can approach me whenever you see me in school. Just stop me. If you have any question about math, I'll be more than happy to help.